Hello and welcome to today's version of the dotnet Runtime and Languages Community Stand-Up. And I am here, I'm Kathleen Dollard. I am the PM for dotnet Languages at Microsoft. And I'm super happy to be here with Bill Wagner and Maoni Stephens. So Bill, hello to you.
Hi there. I'm our second host today, helping, and as per usual, and then our guest today is Maoni Stephens, who's the, I guess, like lead engineer person on everything related to the GC and all of our heap management in .NET. So it'll be awesome. Yeah.
So welcome, Maoni.
Thank you.
Yeah, how are you doing today?
Good. How are you?
Hi. Totally awesome. Totally awesome. Can't wait to talk more with you. So why don't we start with you giving us a quick introduction to yourself, what you do, how long you've been doing it, which I find absolutely amazing. You've been my hero for absolutely forever. And so, yeah, let's get started with that.
Yeah. Hi, everyone. I'm Maoni Stephens. And yeah, I'm the .NET garbage collector architect. And I've been doing GC since I believe the end of .NET Framework 2.0. So yeah, for some of our .NET customers, they may not even be aware of a .NET Framework thingy that exists, still does. It's been a long journey and very fascinating. That's why I'm still here. So yeah, today I think we're just going to talk about anything that folks want to talk about the .NET GC, and happy to answer any questions.
Yeah, it's great. I'm looking forward to that. You know, one of the things that's most amazing to me about the GC is that we thought about it more back in, 2005 or 2000 and whatever. We thought about it more and talked about it more, and it just keeps becoming better and better and doing what you want without you ever having to think about it, which is absolutely amazing. But one of the things that I find from that is that, I can't guarantee everybody knows exactly what the garbage collector actually does. Mm-hmm. And, so if you want to give us just a quick reminder of allocations and what the garbage collector does, we can jump off into more, into deeper topics based on that.
Sure. Yeah. So it's interesting that you mentioned that we talked about it a lot, or we thought about a lot back then. And I do remember that when I went to it was called like not a build like PDC, I think back then, the Microsoft Professional Developer Conference. Yeah. So I think I gave a talk there, the GC, fundamentals of .NET, right? That's the core runtime stuff. That was like center of the stage, and there are lots of people who are asking questions, but I kind of stopped giving talks at the PDC or Build. Now it's called Build, because now, as you mentioned, that you just kind of use the GC features without you even realizing that you're using them. So most of the GC features are of that nature, right? You get a new version of .NET, you just get the benefits from them. And well, sometimes people run into problems, so I have to look at them and fix them for them. But for the most part, yeah, it just kind of happens silently. It's interesting that in .NET 9, which is a release that we just shipped last year, we did put in a feature that, for the most part, I think it, like many other GC features, it just happens silently without you noticing anything, right? Because sometimes people, so keep in mind that like we talk to all sorts of customers, right? Like the customers that I generally work with, of course, they have performance problems, right? That's why they came to me. But a lot of our customers, they're pretty happy. Some of them don't even realize that, the perf numbers of their apps, and rightfully so, right? Because not everybody needs to go measure. I think you should go measure if it calls for it, right? Now, if you say like my app is on a perf critical path and I really need to know about the perf, then you should absolutely go measure. But for a lot of our customers, things just kind of work out naturally, right? So the feature that we introduced in .NET 9, which was introduced as an experimental feature in .NET 8, but in .NET 9, what was actually enabled by default is called DATAS. DATA stands for Dynamic Adaptation to Application Sizes.
Okay.
So I wanted to talk a little bit about that because I think unlike some of the other features where you have to sort of measure to notice the performance benefits, right? You have to go collect the trace and whatnot to see the numbers. This one, for a lot of the people, it would be a pretty dramatic change. And I'm hoping for most people that change would be positive, right? Because with perf improvements, there's always a case where you would make something worse for some people, right? But the hope is that we're going to make it better for the majority of the folks. So data kind of lands in that category. So I wanted to talk a bit about that because, .NET 9 is out, even though it's not a long-term release. I want to talk about this feature. So folks who are still on .NET 8 and they, if they only plan to upgrade to long-term releases, they can still enjoy the benefit or at least try it out, the .NET 9 GC. I'm going to talk about a little bit about how to do that in a very, very easy way. So data is something that we decided to do because a lot of our customers who are using server GC, and that comprises a big chunk of the ASP.NET customers, right? Because ASP.NET enables server GC by default. So a lot of folks were, especially I heard this from the ASP.NET team. So they've been talking about how some of our customers, they observe this large memory usage with ASP.NET apps, and they hope to get this memory usage down, right? Let's say without sacrificing other parts of the perf much, right? Because it's always give and take, right? There's no free lunch. So if you're gonna if you're gonna gain something, you kind of need to sacrifice something else. It's a trade-off for the most part. So that had been going on for a while. So for .NET 8 timeframe, we decided that we were going to really sort of give a solution for this problem. So the problem, the reason why some folks were complaining, right? Not everybody was complaining, right? The folks who were complaining about the memory usage problem about server GC was too generous with the memory usage, right? Which is understandable if you think about the philosophy behind the server GC design goals, right? Server GC was there to sort of fully take advantage of the resources on the machine or on the VM, right? So that was, how it was designed in mind for folks who designed this. That was before me. So what this means is that, well, if I'm running on a 16-core machine, right, by default means that if you're using ASP.NET, if you're not doing any kind of configurations for GC, you're going to be having like 16 GC heaps and 16 GC threads, right? So come collection time, of course, that mostly means that you're in a better, situation than if we only created one GC thread, right? Because you have 16 GC threads doing work in parallel versus one. So, okay, like, the GC would be done much more quickly for the same amount of work that needs to do. However, that also means the heap can grow very large. And this is especially very obvious to folks who have not, I would say medium to small size heaps, right? So we're not talking about folks who have, like 20 gig heaps, right? 20 gig heaps, like when they do let's say the most aggressive GC to compact down the heap size, the result may not be that different from when they're allocating normally, right? So, you allocate a bunch of memory, then if a full GC happens where it collects a full heap, right? You're kind of expecting the heap will shrink by some amount, right? In that case, usually you don't see it shrink by a huge amount because a lot of your heap is holding the long-lived data. So when we do a GC, it's still going to be there, right? So, if I have a 10 gig heap, maybe the temporary allocations make up, let's say, 3 gigs of the heap, and the long-term data makes up 7. So I still got 70% of my heap left after I do the most aggressive GC collection. So to a lot of folks, that's, it's reasonable, right? You have a large heap, therefore you allow more temporary allocations before we do a collection. So that makes sense. However, if you think about a scenario where I have, let's say, a 200 meg of this long-lived data, right? And then I have 16 heaps. Let's say each heap gives you, 50 megs of allocation. That's 16 multiplied by 50, then plus the 200 megs. That's a huge difference, right? So some folks, they would observe, they're like, how come like sometimes my heap can shrink to be so small, like around 200 megs, but then, normally it takes up so much more space, right? That makes no sense to folks. If you think about the design goal of server GC, actually it does make sense, right? Because if you allow more allocations to happen before you do the next GC, yes, you'll take up more memory, but server GC does assume that it can use a lot of resources, right? Because you told it, you're like, I let you use a lot of the resources on this machine as you please. So server GC is like, okay, fine, I'm going to use a lot of memory, because what's memory for, right? You have a lot of memory, you're not using it. So yeah, that's why they observed what they observed. However, you could also imagine the kind of problems that this would cause, right? So for one thing, that we have folks who do, I work with a lot of first-party perf teams, and they do capacity planning, right? So they want to know, like, how much can I fit my process, or how many instances my process can I fit on this node, things like that. So this very dramatic, shrinkage and growth of heap, that causes a problem, right? So they're like, what should I use, right? No, if I use this very generous number, then I can't fit very many instances, and I would like to, because I observe that it can shrink to a very small amount. So why can't I, sort of just plan for that, right? So that kind of makes it difficult for capacity planning. Another thing that has been sort of on our radar for the past quite a few releases is the container scenario, right? So I think first I did the serious support for a container scenario in .NET 3, .NET Core 3. So that has been 6 releases ago. So so for container scenarios, if you think about Kubernetes, people love to be able to overcommit, right? They want to fit in as many container or pods as possible on their nodes. So memory usage, being able to sort of keeping memory usage in control, that is a very important feature for our customers in that situation. So because of all these reasons that we decided to do data, which is, as the name suggests, it's going to adapt to your application size, right? But what does that mean, right? What is application size? So, especially in the GC environment, application size actually could mean different things for different people, but I'll just give what the definition is that we use. So you could think of application size as your long-lived data size, as I was mentioning, right? Which you could sort of approximate as, how much memory objects in your old generation take up. So, meaning that, if I did a full GC, this is how much memory you end up with, right? So you could use approximate as that number. Or, if we want to use a shorter name, I actually call this the stable size in the implementation. So for in order to adapt to this stable size, so we apply a factor to the stable size, and we say that we would only grow the heap by that much when you allocate. So I'm intentionally not telling you what this factor is, because this factor changes for different stable sizes, right? Because if you imagine, like, my stable size is 20 gigs, right? As the example I gave before. Then if I allowed, 2 gigs of allocation out of that, it's very reasonable, right? 10% of your stable size, you have 20 gigs. And but if my stable size is 2 megs, am I only going to be allowing 200K of allocations? That's way too much overhead, right? If you have to do a whole GC just for 200K worth of allocation, it really doesn't make much sense. So of course, the factor becomes bigger if your stable size is smaller. Is right? Yeah.
Makes sense.
And yeah. So one of the situations. So first of all, like when you upgrade to .NET 9, you might observe that your server GC apps suddenly use a lot less memory, right? Of course, this is great for folks who are okay with, let's say, they used to see maybe hardly any time in percent time in GC, right? But now they're seeing maybe it went from 0.x% to 1.5% or 2%, right? They're like, okay, I'm fine with that. I'm totally okay with spending a couple percent of time in GC, right? Then this works out great for them. So I have come across folks, right? I just actually, end of last year, I was working with the first party team who said that we absolutely do not want to increase our percent time in GC because we're totally about, we can't sacrifice any kind of throughput. So then data is not for them. So in that case, you could easily turn it off by just setting the GC config to 0. It's called like dynamic adaptation mode, right? So it's documented in our config page. So if you go to if you search for .NET GC config, go to our configuration documentation page, it's documented there. So then you can turn off. But where this really shines is if you have a bursty workload, which is very, very common for folks for all over the place, right? Think like a typical server app, right? It handles requests, and let's say you have your peak hours, your non-peak hours, right? Mail server, right? Exchange. I heard their peak hours usually is something like 10 a.m. to noon, something like that, right? This is data I got from them many years ago, but I imagine the habit of folks hasn't changed. 10 a.m. is kind of early for me, but I'm sure lots of people are up and about and sending emails. So for them, that's their peak hour, and rightfully, you would imagine a larger amount of memory usage, memory requirement, right? Because you're handling more concurrent requests. You might increase your stable size, right? You might or might not. It depends, right? You could imagine if I have a cache, maybe I would want to increase my stable size to hold my cache data, right? Because I handle more requests, therefore I want to cache more. So in this case, during the peak hours, let's say you have a larger stable size, then data would allow more heap size growth, right, during those hours. But when you go from peak hour to non-peak hours, the workload lightens, right? Then if that means your stable size is now a lot smaller, we would actually adjust the heap size down. So that's where I think, if you have this sort of bursty workloads and you do want to free up memory when the workload gets lighter. If you're in a situation where you're saying like, you could free up some memory, but I have no use for that memory, then why free up memory, right? This is assuming that you are going to use the freed up memory for something else, right? This could be done either naturally when you have when you're on Kubernetes or some kind of orchestration environment, or some teams that actually do their own thing, right? I've worked with teams who kind of manages their own thing. Like if they observe that the available memory goes over some threshold, they would actually start running some batch jobs, maintenance jobs and whatnot that aren't very urgent, but would be good to do like once per day or something like that, right? So if you can use the freed up memory, then you fall into this bursty workload situation. Then this is where data should really shine. So
yeah. So let me make sure I understand you on that. So the this adjustment for like time of day and load, that just automatically happens?
So the workload on its own, that happens because of your own app, right? So let's say your mail server, it just needs to handle more mail during 10 to noon, right? So then we would observe that. The way we observe that is by observing your stable size changes, right? So when we do a GC, we realize that, when we do a full GC, right, we realize how much stable data you actually hold in your heap, right? And then we will adjust based on that. That gives you, the maximum of the heap that you can.
Yeah. So if your stable size goes up and down throughout the day, then it's just
then you would
never think about it. That is so cool. That's absolutely amazing. This stuff is great, and I love that you can turn it off because,
Yes.
as you say, it's like it's not going to be the perfect fit for everyone every time, and that's true over time. And I guess the one question I'd have on that is, if somebody is listening to this and is wondering, how do I know whether it's good for me or not good for me? Is that just a profiling question, or is there a way that people can?
Usually the way that I ask folks to start a perf investigation, or, you don't necessarily have an issue, you just want to get an idea of how the memory perf is going in your app, is the simplest way is by taking like a GC collect only trace. So this is written in my memdoc. I have a little repo that has a document called memdoc. I think, if you could find it and pull up the link. So I talk about like how to collect a top level GC trace. So in that top level GC trace, it's top level, but actually tells you a very rich set of information, like how many GCs happened, when did they happen, how long they lasted, how much they promoted, blah, blah. I think there's like 60 or 70 data points we give per GC. Okay. So you can, kind of, it's actually a really excellent set of information that you can go as deep as you want at if you're doing the perf looking around or investigation. So you could take a trace. You can also see like how much your heap changed, right? So you could say like, oh, with server GC, let's say I was using .NET 8 and I didn't do any configuration. So in .NET 8, because this was an experimental feature, you had to turn it on by yourself, right? Using the same config, you could turn it on. So if you were using .NET 8 and you did not turn it on, you could take a top-level GC trace. And then if you use .NET 9, you can take another top-level GC trace. So you can see exactly how much your heap size has changed, and how much the percent time in GC has changed. Yeah. And then, of course, the number of GCs. So, if we're going to limit the heap growth, right, naturally that means we will do more GCs. Right, because we allow less to be allocated before the next GC happens. So you can take a look at the two sets of data and make a decision. And I think for most folks, this decision should be very obvious, right? You should be able to say like, yep, I'm good with the much smaller heap size and with maybe a couple percent more percent time in GC increase, right? Because a lot of the apps they're not really CPU bound. Right. Many of the processes that I've seen, they're not like CPU saturated. So they can afford to maybe sacrifice a little bit of a throughput in exchange of a much smaller heap. If you look at the data and you're like, oh, no, I like the .NET 8 behavior better, you could just set the config and turn data off.
That's awesome. That's totally awesome. So I think we ought to take a break now and pull some questions out of the chat. Bill, do you have a couple?
I had one quick first as we follow up. Your whole discussion was focusing on server GC. Is this available in the client GC, or is it just not really apply there, or is it just?
So this does not. Well, that's an excellent question, though. So this is on by default if you already have server GC on, because the whole thing was there to help with server GC scenarios. For folks who are using workstation GC, as with pretty much anything perf, there's very rarely 0-100%, right? It's kind of in the middle. So for this particular case, like let's say I was using workstation GC, which means I probably don't have a very large heap, right? Because workstation GC only ever collects with one GC thread. So in order to handle all that GC work, it might it's going to take a while if you have a large amount of memory to process, right? So by the virtue of me using workstation GC, that should mean that I don't have such requirement to collect a lot of GC, or I'm okay with the amount, the GC pause or GC amount of GC work that's incurring, right? So if that were the case, then you don't really need data, right? Because workstation already kind of keeps a heap fairly tight. However, I think there's one situation where if you are using workstation GC, you might actually turn on server GC just to see if data would give you any benefit, which is like, I was okay with the heap size, and I was kind of hoping to see the GC pause to become shorter, right? Wouldn't it be nice if I can still keep my heap kind of small, but the GC pause would become shorter because I actually had a significant enough amount of memory to work on for GCs for me to want the pause to be smaller. In that case, you actually would kind of want to try out data, right? You just need to turn server GC on and you automatically get data. So yeah, that would be a case where I would be curious to try out. And yeah, if you're on .NET 8, and for a lot of people, doing upgrade from one major version to the next is no small feat, right? So it might cause problem. I mean, there's so many changes that go in for each major release. So occasionally people would come across problems, right? So, but if you just want to try the data in .NET 9, you don't have to upgrade at all. You could just get the standalone GCDL from .NET 9, which is called CLR exp.dl. You can just use again, the same config page that Bill pasted a few minutes ago, that there's a way to specify a config to use that standalone GC instead of the GC that's included in the core CLRDL. So you don't have to upgrade at all. You just need to set that one config and you can try out the .NET 9 GC.
Cool.
Yeah.
So I'm taking some of the questions out of order just in terms of kind of matching what we've been talking about and working that way, just so folks know. So Jose Silva, the question: I have a .NET software that works in 500 millisecond cycles and specs an image or several images on a production line. So in that kind of a scenario, would I want to call GC collect after each one of these cycles?
So that depends on a lot of factors. For example, how big is your heap, right? First of all, if you are to call GC collect, let's say with no arguments, I think, now we have quite a few overloads on that API now. I think there is an overload from way back that has no argument that just collects the whole heap in the block-in fashion, right? So this is not going to be done as a background GC. If your heap is anywhere more than, let's say, a few tens of megs or so, then you probably don't want to incur GC every 500 milliseconds, right? Because the whole overhead of doing a GC is going to be noticeable, right? So I would, first of all, like I said, the best way to start this sort of investigation is to collect the top level GC trace, right? Then you have an idea am I interrupted by a GC? How many cycles am I interrupted by the GC after my 500 millisecond cycles, right? So you can at least have an idea am I okay with the frequency that it's getting interrupted by the GC now? If I am, then I wouldn't do anything, right? However, if you're I would like to see if I can get my heap size smaller. Well, first of all, you might want to try out data, but if you just want to see maybe I want to call this, after my heap is, some, over some threshold, right? You could do some heuristic like that. But let's say if each GC is already taking 10 milliseconds, right? Then do you want to sort of, induce a GC every 10 milliseconds? I think that's a question that, are you okay with that, right? That's not really a question I can answer for you. So, this would require you to do a little bit of an investigation to see first of all, if there's any need to. Secondly, if you were to induce a GC to see if you can get the heap size down. By the way, I don't even know why you would want to induce a GC, right? That's again a question you have to ask yourself. So if I would want to induce a GC to get my heap size down, then should I do that every cycle or every n cycles? Right?
Yeah. Okay. So I think of this as a rule of thumb is most people most of the time don't need to adjust the GC. They should use the one that's the default and just go with it unless they think they have a problem or they're in. And this sounds like it's a production line. Yeah. So this is a situation that's going to have some very heavy time, time element to it to keep the production line going. So it might be one where there's a little bit more performance concerns, but most apps GC just works. That's the great thing about the last long time is that it does just work. So
right.
Yeah.
And like I said, if you're even curious, you may not have any problems, but if you're curious to see like, hey, can I make some perf improvements to my app, right? By the way, that's, I love it when people say that, right? Yeah. Not everybody needs to say that, because for a lot of people, like, their time should be spent on, churning out features, right? Because perf just isn't an issue. But if you want to see, like, where is my perf at, and is there any room for me to even do some, reasonable amount of work to get some noticeable improvement, right? Then the best way is to collect a top level GC trace and just take a look at what your current situation is, right? And then, yes, please read memdoc to find the sections that apply to you, right? Memdoc is organized in a fashion where you can say like, oh, I want to see my heap size smaller after GC, right? If you're in that category, then there's a section for it that explains to you like what is contributing to your after GC heap size and how can you improve that.
Mm-hmm. Right. And then one kind of related from George is a question. Is there any plan to support a pauseless GC, or would it be possible to make it easier swapping the GC with a custom one?
So yes, it's absolutely possible to swap the GC with a custom one, because as we just mentioned, that you can just load a standalone GC, right? You can write your own standalone GC if you like. You just need to implement an interface that our standalone GC implements, right? Then you can get it loaded with the core CLR, and it'll be used in your GC. So I have folks ask this pauseless GC, right? So there's not really any GC that's actually pauseless, right? There was a GC that's called pauseless, but there's no GCs that's actually pauseless, right? When you do work, if GC is doing work, it means your thread is not doing work, right? So that will show up as pause for you. And as far as like, I think this gentleman probably meant to ask like, do we want to support sort of ultra low latency GCs, right? So we definitely had, I definitely wanted to do work around that realm. So interestingly enough, it was actually around the same time I was deciding if I should do that or if I should do datas, right? They're serving very different kinds of customers, right? Folks who want the ultra low latency GCs, they're usually in a sort of soft real time realm that most people are actually not in at all, right? Most people don't care about having like real time or soft real time. They're it's okay to as long as it stays under some number that's not too large. They're okay with it because they just don't. Their perf requirements just don't call for it. But as far as like sort of like if you're asking me like, are we planning to support a concurrent compacting GC, which is supposed to produce low latency on the GC side, right? So I want to be very careful and say this is low latency on the GC side, because right now, if you need to do a compaction, right, that we do it in the blocking fashion or the stop the world fashion, which means that while we're doing the compaction, we're performing this compacting GC, your user threads will be paused. So yes, like your user threads will be paused for an entire duration of that GC, right? Concurrent compacting GC allows you to actually do the sort of moving objects around, but still allow the user threads to run concurrently, right? So that's why you can say it from GC side, right? GC's perspective, we're providing low latency. However, that is very different from whether you would actually observe low latency from your perspective. Mm-hmm. Right. So I want to explain like the difference between the two, because I feel like this question was asked, quite a few times, and I want to, kind of have the answer reach out to more people. So let's say I have a request that takes up 3 milliseconds, right? Okay. So that's I think for most people, that's a very reasonable amount of time to see, of course, request is very app dependent, right? You could have a request that takes 10 seconds, I could have a request that takes 1 millisecond. But let's say it takes 3 milliseconds, right? Let's say we had a concurrent compacting GC. So from GC's perspective, each time GC does work, it's no more than, let's say, 10 microseconds. Okay, so that sounds good, like so far. You're like, well, you're only pausing 10 microseconds. That's so short. But imagine if GC has to continuously do this 10 microsecond work all the time, right? Which again, it may not leave much time for your threads to run anymore either. So just because GC is producing very short pauses, that doesn't automatically translate to your request will now seem shorter. Right, so there's a distinct difference there, and but to answer a question, do I want to do some sort of like ultra low latency GC? As a GC person, of course, but as a person who works on the GC that serves millions of customers, I have to think about the customers who take up a big chunk of our customer base, right? So data was actually a decision that was exactly because of that reason, because we have a ton of ASP.NET customers who would like to see their memory usage go down with server GC. So that was actually the reason why we did data to begin with. Mm-hmm. Yep. But of course, you're welcome to write your own, custom GC, because we totally provide a mechanism to do that.
Okay. So then we get on some of the inner workings as it relates to some things that are going on in languages. So how does the GC translate interior pointer, like say a spans address to the start of, say, a slice out of an array or something, to the start of the object during its mark phase?
Yeah. So we have this data structure called a brick table. So brick table is I think people have asked like why it's called brick table. It was a name that was, given by my predecessor. So he decided to call it brick table. So brick table is something we use that when you're given a pointer that points in the middle of an object, we use the brick table. We basically go back to the brick that records the beginning of an object. So we know like that's a starting of an object, and we record it in this little space in the brick table. Then we just start going from there, and we know that that's the object that holds your interior pointer. I think this is, if you have Kokosa's book, the Pro .NET Memory Management book, I think those guys, they actually just published their second edition. This was explained in there very clearly. So, yeah.
Okay. And then let's see, there was another one that was a kind of similar area is, does the plan phase for a Gen 0 collection work on in an individual region when calculating the offset, or on all of them together?
Okay, it's interesting how folks are asking about these internal questions. I love internal questions. So plan phase for any sort of blocking GCs that we do, right? So plan phase only happens for blocking GCs. For background GCs, we don't do plan phase, because plan phase's purpose is to decide whether this GC would be a compacting GC or would be a sweeping GC. For background GC, we know it's going to be a sweeping GC, so there's no point to have a plan phase there. So for any, Gen 0, Gen 1, Gen 2, if done as a blocking GC, they will all incur this plan phase. And each plan phase will start out, let's say you're using workstation GC, you only have one GC thread working, only has one, which means that GC thread will be managing the whole heap, right? So we don't work on individual regions, right? We work on, sure, of course we go to individual regions first, because there's a list of regions that, if you're doing a Gen 0 collection, it's going to work on all the Gen 0 regions, right? So it'll start the first Gen 0 region, it goes down the list. For each region, it's going to be, calculating it's going to make a plug first of all, right? Making a plug consists of, you look linearly through the objects that were worked on by the mark phase. So plan phase will know, like, is this object marked? Yes. Is this object marked? Yes. So then, because they're right next to each other, they will form a plug, right? A plug is essentially an adjacent group of live objects. So if I look at the third object, that object is not marked. It's not going to be part of a plug, right? So if the fourth object is also not marked, these two dead objects will be made into one free object, right? And then for the plug, then we build a bunch of other data structures. One of them is to store the relocate address of this plug, right? So we don't move by objects, we move by plugs. So for each plug, we'll say like, where can we fit you? Then we'll store that, the difference between the new address and the old address in front of the space in front of the plug.
Okay.
Right.
And then one more internal or future such, also from George. Is there any plan to make the large object heap defragmentation automatic, or is this still too heavy and expensive of an operation?
So LH is already defragged automatically if you're in a container scenario, which means, translate to GC terms, is if you have a hard limit specified for the heap. So if you have a container and you specified a memory limit on it, right? In Kubernetes, you could specify like for each pod and each container, you can specify, I want, the limit for it, right? The memory limit for it to be like, let's say 500 megs. So the 500 megs will be then, if you're using Linux, it's going to be set through some C group value. And then we will read that C group value and communicate that to the GC. So then GC knows like, you're in this, what we call the memory constrained scenario, which I just kind of shortened it to a container scenario, right? But container with a memory limit, of course. So if you're in that scenario, then LH is already compacted automatically. So we do have some perf heuristic to compact it when needed. Another scenario where this is already happening automatically, of course, this means that you're doing some config on your own, but in that case, LH will be defragged automatically is if you're specifying the conserved memory config, right? So again, this is documented in our .NET GC config page. So if you serve for conserved memory, there's a config for it. Conserved memory is a number that you communicate to the GC to tell it how conservative you want the GC to be. Right? So if you say, if this value is very high, you're saying be very conservative with the heap size, which means GC will be more aggressive at shrinking the heap size. And that includes compacting LH if necessary.
Okay. So one more very kind of low level but practical one from Jeppe is there some good documentation about how pinning works together with the GC? And should I need to worry about pinning when doing lots of DSP processing? I don't know if that's digital signal.
If you want to clarify
if it's different on mini, medium, or large arrays.
So I do explain about pinning in my memdoc. So feel free to take a look there. I think I give a pretty detailed talk. This was probably right before the pandemic at the at COCOSA's the .NET Performance Conference. So I specifically talked about pinning, why pinning is hard for GC to handle. I think if you search for like, why is pinning hard, .NET GC, or my name, you'll probably come across that talk. It's online somewhere. Whether should you worry about pinning or not? So again, I encourage you to collect a top level GC trace, right? You see a pattern now, like when you ask me these questions, like the reason why I can't just say like, yes, it is a problem for you, or no, it's not a problem for you, because this is very app dependent, right? Most things in GC, like how memory is working, how memory is laid out, is very app dependent, right? Because we don't know when you're going to pin something, right? One of the things that makes it hard about pinning is you can pin anything that you allocated, right? There's unfortunately no limitation there. If you can get a hold of an object, you can pin it. So you could be pinning like all scattered the heap, or you could be very good about keeping them very tightly grouped together, right? So I don't know what situation you're in that for this gentleman. So this is why you want to take a top level GC trace and see like if pinning is indeed a problem for you or not. It may or may not be. If you're very, let's say I pinned a bunch of like very stable objects, meaning like they're long-lived, they're probably already not going to move anyway. Then pinning, if an object doesn't move, pinning it or not makes no difference, right? Pinning only makes a difference when GC decides to move something. If the object is already in this very compact part of the heap and doesn't really change, then you could pin, all you want. It makes no difference to the GC. Oh, thank you, Bill. Yep, that's
Yeah.
This is why we're here.
Awesome.
Absolutely. Bill does such a great job on taking care
absolutely, yes.
And I would say, depending on the version of C# you're using, if you're looking to avoid allocating the memory and then pinning it, look at some of the new features in C# where you can stack alloc something into a span. And, if I don't know what numbers you're talking about for medium large, but if it's short-lived and on the stack, you can stack alloc it right into the into a span, process it that way, and then
there's also in .NET 5 we introduced a pinned object heap, right? So if you which of course means that you're pinning something as you allocate it, right? So this kind of takes away that very broad, like non-limiting thing that we have about pinning things, right? The previously you just pin whatever. Now we're saying like if you are in charge of the objects that you're actually allocating, because for some folks this is not really possible because they're not in charge of allocating something. They just want to pin it because they need it to not move for whatever reason, interop, right? But if you're actually in charge of allocating that object, you could actually be pinning it as you allocate it. So that way we can just put them all together, right, in one region on the heap. That usually makes things better because they're not polluting everybody else.
Okay, and then were you gonna add something, Kathleen?
No, I just said that's cool.
Yeah.
Okay.
Yeah.
So 2 good questions to kind of finish up on. One, Jose had asked quite a bit earlier. What do you recommend to learn how this works underneath the hood? What's this design? Book, course, repository? I know you mentioned MemDoc. You mentioned another book by a few authors.
Yeah. Right. So I think MemDoc is for you. Of course, you could go read it if you're interested, especially in perf. I recommend everybody who is interested in perf, is just curious about perf, to read MemDoc. Right. And I specifically, and please give me feedback. Right. I want to make this doc more approachable to more folks. But I try to write in a way that, it is a long doc, right? I think it's probably 80, 90 pages. But, the hope is that you don't need to read all 80, 90 pages, right? You just go look at the index of the topics and go to the topic that actually interests you, that you care about. So I would definitely recommend you to read that. If you want to know like how GC works in general, there's the Pro.NET Memory Management book from Conrad Kokosa. So they just had the second version. I think they gave me the second version. Is very thick. It's a very thick book. So that one has a lot of drawings, because he is very much into the illustrations, and he did a great job in illustrating the data structures. So for example, somebody asked like, how do you go from the interior pointer to the beginning of the object? So that's all explained with illustrations in that book. So I recommend you to go read that book if you're interested in the inner workings of the GC.
Awesome. And then the great one to look forward to, Benjamin had asked earlier, has there been any recent academic research in the garbage collection in general or memory management in general that could be interesting for the .NET GC? What are you looking at next?
So it's interesting that you asked this question. So I was reading this paper by students, but his name's also on the paper. This ref counting GC that's augmented with the trace GC. So it's from Steve Blackburn. So he's a long-term GC researcher. He's very active in the GC community. If you read GC papers, you probably inevitably come across his name. So I was actually very interested in the ref counting GC. So because ref counting kind of inverses the trace and GC's work, right? Ref counting GC cares about the dead ones. Trace and GC cares about live ones. if you think about the old generation collections, right? Old generation, when you collect them, usually you end up with very high survival rate, which means there's very few dead objects compared to young generation collections, right? If you do a Gen 0 collection, usually, especially in a well-behaved app, like 99% of memory will be dead. So it makes sense to work on the live memory, right? But if you think about the old generation collection, it makes sense to work on the dead ones if you can. Of course, rough counting GCs, like they pose their own challenges, right? How do you collect cycles? People have had all sorts of ideas, and I think that paper, I liked it quite a bit, and I actually was seriously thinking about sort of seeing like how it would adapt into our world. But again, this was like on the time frame when we started, when I almost started doing something in that area, but then we were kind of preempted by data because we just really needed to help customers with not just like a big giant app that can take up as much resource as it wants on the machine, that kind of thing. Because I felt like the releases before that, we were mostly working with folks who had very high perf requirements that had that scenario, right? Like, all the big apps, like the server apps that handle some of the largest workloads in the world, that kind of thing. So we concentrated making perf improvements for those scenarios a lot. Like we did a bunch of, perf optimizations that would reduce pause time and whatnot. So, in .NET 8, we really need to take care of, folks who are not just like handling like these giant workloads, right? Because actually a big chunk of our customers don't land in that scenario. So, but yes, there's definitely interesting research papers. I read them all the time anyway. So I think there's going to be another paper that's going to get published soon, because I was talking to the authors, and that they actually did a bunch of research in this ref counting GC. So I'm excited to see like what they came up with. Yeah. So has there been anything interesting? Absolutely. But as a team who works on a pretty mature product, we have to prioritize our work accordingly. So
sounds good. Yeah, and it's definitely used by incredible numbers of people and huge amount of code out there. And that's pretty much cleared the list of questions. I'm going to say we also have just a tremendous number of comments from people thanking you for being here. And
of course, I'm happy to be here. Yeah,
answers and such detailed answers. So
yeah,
my job is super easy. So
yeah, it's absolutely great to go deep in something that at least I take for granted all the time. I think most .NET developers do take it for granted all the time, which we can, because of all these details that we're kind of good for.
And my hope is that most .NET developers should take it for granted, right? Yeah. It's only for folks who want to, who need to care about perf and that sort of thing. So yeah.
Or they're curious and they want to run.
Exactly. Yeah, the curious ones.
Find out what's going on, which is great. And it's so great. You can get all that information just to satisfy your curiosity about your own app without really feeling like it's the tip of an iceberg of something you have to solve. And
I'm the kind of person who would prefer to not ask folks to do like a mountain of work just to get a little bit of data, right? And I don't think we're in that situation, right? Like I said, if you collect a top level GC trace, it's a one-time cost to download our .NET Trace tool, and you give it a command line, you collect the traces. It should be all very trivial. If it doesn't work, of course, you should, enter an issue in our repo, right? So our diagnostics folks can fix it. But it should be a very trivial task to do. But you get a lot of info, right? So I think it's a worthwhile thing to do if you need to investigate perf or if you're just curious. Absolutely.
Yeah, that's so great. Maoni, thanks again for joining us today. It's
My
always
pleasure.
a pleasure to see you, and always great to work with the folks that come online with us when we do this almost every month. And it's so great. Thanks everybody who's with us today, and thanks for your great questions. And thanks, Bill, for doing a great job co-hosting this. And with that, I think I will say goodbye and send us out.
All right.
Thanks so much, everyone. And thanks, Bill and Kathleen.
Yep. All right. Thanks, everyone. And thank you for attending another stand-up. Let's see.
Okay.
Yeah.
Log.
Yeah.
Out. All right.